So let us study about stress. So stress is defined as it is defined as the restoring force per unit area. So we can write stress is equal to restoring force upon area. This is how we can define the stress. What are restoring forces? The materials have elasticity. Materials have elasticity. Elasticity is the property to it is the property to regain the original size. Original size. Now, whenever the deforming forces, there is a concept of deforming forces. Deforming forces comes into action at that time. There is a small elongation. There is a small elongation in the material in the body, and this produces a restoring force between the molecules. So this produces restoring force. A very good diagram is given in the textbook for the materials. Molecules here arranged in the lattice. Between them are the intermolecular forces. These intermolecular forces are shown with the help of springs. Springs are in all the directions. From any direction, if this material is pulled by the deforming force, then these springs are pulled, and opposite to the deforming force, a restoring force is developed. Hence, the body has an elasticity and able to restore itself. What is a strain? Let us see it. It is the change in the dimension to the original dimension. Now here dimension means the size. Dimension here means the size, we can say. So therefore there are three kinds of strain. The first is longitudinal strain. A very good diagram is given for the longitudinal strain in the textbook. That is for a wire. Here we draw a wire to show its cross-section area also A, and one end suspended from the roof. It is suspended freely and some weight is applied, so there is some force. This force is longitudinal force, so there is some change in its length, which was originally L. So let us say that its change is delta L. Delta L is the change. So we define the longitudinal strain as delta L by L. It has no dimension. This quantity has no dimension, no unit. The second type of strain given is volumetric strain. In this, it is defined as the change in volume per unit volume. A very good diagram is again given in the NCERT for any object which is spherical in the shape and from all sides normally some force is applied, so it makes a change in the pressure delta P, or it makes a pressure P, due to which there is a decrease in the volume. So decrease in the volume, if we denote with the minus V, so we get minus V by delta V as the volumetric strain. Again, it has no dimension.